Hello guys, in this video I'm going to show you how to solve equal subset sum problem. So given a set of positive numbers 5, we can partition it into two subsets such that the sum of elements in both subsets is equal, right? So let's say we're given a array of 4 numbers 1 2 3 4, right? So want to see if we can partition this array into subsets. So partition it into two subsets, right? So for example, one subset can be 1 2, the other can be 3 4, or 1 2 3, the other one is 4. The sum of elements in both subsets is equal. So it means if the total of all the elements in this case is let's say 7 plus 3 is 10, right? So each subset will be must be sum up must sum up to 5, right? So our goals is so the original requirements can be translated into 5. We can partition into two subsets, right? Into two subsets. The sums of elements in both is half of this total sum, right? So the target sum is 5, right? In this case. So the most intuitive and naive way to just try out all the possible combinations that we can have here. So we're gonna start with we're gonna iterate to every numbers in our list, right? So start from 1 to 2 3 4, right? So at each number wanna use wanna have two options, right? Either pick the number or skip the number, right? Here I can pick one or I can skip one. Same here. If I pick one, I will move to the next number, which is 2, right? I again have two choices, which is take 2 or skip 2. In this branch, I also have the same choices. So same as 3 and 4, right? You can see we have a kind of a tree. So for example, wanna look at one path from root to leaf is one possible subset we can have, right? So one possible subset is 1 2 3 4. Another is 1 2 3. here we skip 4, so 1 2 3, 1 2 4, 1 2. Another one is 1 3 4. Last one in this branch is 1 3, right? So by doing this, by having two choices at each number, at each layer of our tree, our, our binary tree, I can brute force to for all the possible cases here, and so a subset that is satisfies the requirement is a subset that sum up to 5, right? So looking at here, we can see it is the subset 2 3, right? 2 3. So it's here. We skip 1, take 2, take 3, and skip 4, right? So here is a subset that satisfies the requirement. So to solve this problem, we can use recursive. Gonna use recursion to kind of recursively check our problem. For example, if we are here, if we are at node 1, right? So we have two choices, which is take 1 or skip 1. So our problem is can be delegated down to the tree. So the question that we make the question that we make at 1 is, can we find a path that sum up to that sum up to 5 minus 1, right? Because here we are asking questions for from 1 to each child. No, can we find a path that sum up to that sum up to 5 minus 1, right? Or if we skip the 1, the question should be, can we find a path that sum up to 5, because we skip 1, so we don't count 1, right? So it will be clearer when we write code. So wait me a minute. Okay, so let's code it down. So I have a function can partition equally. In this one we return true or false, which means whether we can partition it into two subsets of equal sum, right? So Yeah, we need to calculate the sum of risk factors, right? So let's say const sum equal to numbers. I'm gonna use reduce here to calculate sum of all the number in the array A plus B. Okay, okay. We have sum, so uh, here we can check if the sum is a odd number, then we're gonna just return false right away because there's no way to divide the uh, odd number into two subsets. Right? So if sum module 2 is equal to 1, then I'm gonna return false. Right? So const half of sum, here is what we want, the target sum divided by 2. Okay. So because uh, wanna use recursion, right, to recursively asking questions, then probably you want to do something like the DFS. Okay. Uh, what is the questions? Uh, what kind of state we need to keep here? Numbers. We need to we need at each node, for example, at each number, we need to know what am I currently at. Like for example, I am currently at this one, right? Then uh, I need to know where I am at so that I can update the state. I mean, um, for example, if you're two, right? So we must have a way to call for the next recursive call uh, where we can where we can process three, right? So probably I can in this case I can use index here because we're iterating for every number in the list. So for example, at the first iteration it is at the first iteration is index 0. It means I'm processing 1 here, right? So function dfs, okay, uh, all numbers and the current index, right? What else we need here? The current sum, right? The current sum. mm, the target sum to be exactly. uh, so for example at 1 our target sum is 5, right? And if we take 1, it means I'm gonna subtract 1 from 5. So here, at this branch, the target sum is 4, right? So probably I want to keep a target sum, right? So I think we need to keep an eye on these states. DFS numbers. The current index is 0. Target sum is initially is the half of sum, right? Half of sum. This one will. This here questions like, can I find a path to sum up to this target sum starting from number at index 0, right? So this will return true also. So this will give us the answer for this one, the original, right? So now for each current index, right? So here's a recursive call. I probably I must have a base case to avoid infinite loop. Recursive call, right? We have two choices here, right? Which is skip, take current num, take current num, and false. The second choice is skip current num. So at each node, right, at each number that we are processing, we have two choices. Either take the number current number or skip current number, right? So I'm going to return. So the questions is, so if at least I can find, so let me explain it again. So for example, if we are node 1, right, we have two possible ways to go, which is left left child, go to the left or go to the right. Here you can see either go this way or go this way. So if at least left or right, if at least either one of these two cases is true, we're gonna return true, right? So I can do something like return and skip, right? So want to add implementation to it. Here is just a recursive call DMS. So numbers is the same. Current index will be the next one, which is current index plus 1, and the target sum will be target sum minus current number, right? Because we'll take it. So a target sum minus current number is numbers at current index, right? Here is same because you call numbers current index. Next number is current index plus one. Because we skip it, so the target sum is the same. Target sum. So definitely we don't want to keep repeating to infinite, so we must have a base case here, right? So what is the base case here? So if we out of out of range, it means it is when if current index equal to numbers of length, it means we're out of range here. Then I'm return 4 here. So so here I think we can return right away. We can return immediately if we are how to say, if the we can return immediately if the current numbers is equal to target sum, right? If current numbers, for example, here the target sum is 5, right? So we skip the current numbers, so here target sum is still 5. Here if we take 2, and target sum is 5 minus 2 is 3, right? So on the next iteration, we have 3, right? And the target sum is 3 also. So in this case, we can confidently um, we are sure that we have a subset, a branch. We have at least one possible path that sum up to 5, even if we haven't reached the end of the space, the end of the out space 1, 2, 3, 4, right? So all right. So if the current numbers the current number equal to target sum, I'm gonna return true right away, right? So if we are out of range, I'm gonna return false. because if we are range, it means we couldn't find any correct path before that, right? We have a check for every at every recursive call that is the current number is uh, if the current numbers is a correct one. So if we are out of range, mean we can't find it along the way, right? So okay, the base guy. If I miss anything here, anyway, there's one check we could add here, which is probably we don't want to take a number if the current sum is the target sum is already greater than no sorry, the current numbers e greater than the target sum, right? So probably if uh, if the no I think okay, so if the current numbers e greater than the target, then we'll just wanna skip it, right? We have only one choice, skip it here. So let's take the number is 4, right? So only if the only if the what is that? The current number is numbers at current index is less than or equal to target sum, right? Or less than target sum, because if it's equal to target sum, we're gonna stop here, right? So if only if this is the case, I'm gonna go this way. Otherwise, default to false, so that we can skip unnecessary recursive calls. Okay, we have two choices: either take it or skip it, right? So either one of these is true. The current recursive call is true, right? Okay, I'm gonna run it. Just 15 2. Okay, we have 3 passing tests. Okay, it's been a long video, I think, so maybe in the next video I'm gonna show you how to optimize it, implementations, so that it scales well for different fast for when input, even input, enlarge, right? So thanks for watching. See you on the next video.